Hi there, welcome to Ohio Energy Project Virtual Lesson 3, Electrical Lighting. So if you'd like to follow along on the student guide, the guide can be found at ohioenergy.org/students and families, and we'll be starting on page 38. So what is electricity? It is a secondary source of energy that you need a primary source of energy such as water, wind, coal, fossil fuels, etc. to make electricity. So how does it get to your home? So it starts off being made at a power plant, then it's sent into the electric grid, and then it is sent along distribution lines to your home. You can see these overhead sometimes, or they may be underground. So what are the units we measure electricity in? We measure in watts, kilowatts, and kilowatt hours. So a watt is just a standard to measure electricity. A kilowatt is 1,000 watts based on the metric system, and we measure the energy usage in our home in kilowatt hours, which is kilowatts per hour. So we have three different types of light bulbs here. We've got the incandescent bulb, we've got the CFL, and the LED. So the incandescent bulb only converts 10% of the energy it takes into light. The CFL is better than the incandescent, but it does contain mercury, which is not good for the environment. And we have the LED, which is our newest and best bulb. So to continue in our investigation, we will answer a few questions. So what is the difference in thermal energy output of different light bulbs? What is the difference in light output of different light bulbs? And how do light bulbs compare in the amount of energy used? So to do this, we're going to have this set up. We need 3 lamps, which should be identical. We need 1 bulb of each kind, which we have in the lamps already. We'll also need 3 thermometers to measure the heat output in Celsius, and a kilowatt meter and a light meter to do this experiment. So we also kept the packaging of these bulbs to write down the stated watts and the stated lumens on our data sheet. So sorry, down here, 60 watts, 500 lumens, 13 watts, 900 lumens, and 9 watts and 800 lumens. So the kilowatt meter we'll use at the end. You just plug it in between the plug for the lamp and the outlet, and it will read us the energy in volts, amps, watts, or hertz. We are looking to use watts. The light meter, we can take the cap off and we'll place it underneath, and it measures the amount of light that is coming out and reflected. So we'll use this after we do the temperature experiment. So to do this, we will plug all the lamps in and turn them on, and we'll have an initial temperature set in Celsius that we'll read off of these and write down. Then we will measure 2-minute intervals of temperature change and then go from there. So I will do the experiment and then come back with the data. Okay, so now I've finished the temperature readings for the 3 lamps. So I did 4 minutes, but if you were to do it, you'd do 10. This is page 39 of the student guide if you'd like to follow along. So before we go over the data, we're going to measure the light meter reading and the watt reading, kilowatt meter reading. So we'll start off with this. We place it underneath the lamp and just give it a second to get a reading, and then we'll write this down. So it measures in foot candles, which is a standard unit of measure for light. So it's measuring at 1,100 foot candles. So this is the incandescent bulb. Now we're moving on to the CFL, which is measuring at 1,530 foot candles. And then we'll move on to the LED, which is measuring at 1,514 foot candles. So now we will turn all of these off and do the kilowatt meter reading. So to this, we're going to unplug each bulb and then plug in the kilowatt in between the outlet and the plug. So this will give us a reading of the watts that are being used by each bulb. So the reading for the incandescent bulb is 56.5 watts. The reading for the CFL is 14.9 watts. And the reading for the LED is 9.6 watts. So, as to go over data, the change in temperature for the incandescent bulb over 4 minutes was 9.4 degrees Celsius. The CFL was 1.9 degrees Celsius, and the LED was 1.5. The light meter reading was 1,100 for the incandescent, 1,530 for the CFL, and 1,514 for the LED, and 56.5 watts for the incandescent, 14.9 for the CFL, and 9.6 for the LED. So to move on to our questions, number 1, rank the bulbs in order of brightness, the first being the brightest. Does this ranking reflect the ranking of the bulbs according to the lumens listed on the package? Explain why. So, the brightest was the CFL with 1,530 foot candles, followed by the LED, then the incandescent. So our stated lumens were 900, 800, and 500. So this does accurately reflect the brightness. The numbers aren't exact, but this is data, so it's not always going to be exact. Then number 2, the 3 bulbs emit light using different methods. Based on your observations of temperature change, which bulb do you think is the most efficient at producing light? Does it agree with the watts recorded on the kilowatt meter? So, the incandescent is listed at 60 watts, and it reads at 56.5. The CFL states 13 and lists at 14.9, and the LED states 9, and we read 9.6. So, the LED has the lowest watts reading, and it also happens to be the closest to the stated value, but it would be the most efficient at producing light because it produces the second highest lumens amount compared to the amount of watts produced, and it's a very close amount of lumens, so you really couldn't tell the difference. So, in conclusion, to save energy in your home, you have a variety of ways to do this. So you can switch from these incandescent bulbs to CFLs or preferably LEDs. You could turn off lights when you leave a room. Also, you can use sunlight as a natural free energy source. So open curtains, blinds, anything helps. So this concludes the Lesson 3 electrical lighting lesson from Ohio Energy Project. And if you'd like to check out more videos on experiments, please go to our website. And thanks for watching.